Hello everybody, Root Beer here, and I'm going to be starting another math contest, another written contest. It's going to be the 2012 Hypatia, okay? So if you haven't tried this contest before, I really encourage you to click the very first link. It will get you a copy of this contest, download it, print it out, try it for yourself, give yourself exactly the time you need, and try the contest under actual conditions. So I'm going to assume that you've gone ahead and done that. And let's take a look here. So, 2012 Hypatia, boilerplate, the sponsors that we've got here. But in terms of how much time, it's 75 minutes. Okay. So, if you want to try it, print it out, give yourself 75 minutes. Note that you can have a calculator. Calculators are absolutely allowed. And one thing to keep in mind, there are two types of questions. The short answer, where you can get full marks just for your final answer, although I do encourage, and I will be writing up a little bit as well, but I do encourage you to, give at least a little justification, because if you get it wrong, if your final answer is wrong and you don't have anything else, you've lost some marks that you could have, some part marks. Okay? And then, of course, there are the full solution questions, and they are, you have to justify everything, you have to state every formula you're going to use, that sort of stuff. Okay? But as I say, try it out before you watch these videos. I try and mention that at least once per contest. But you guys really, that's the best way to do this, is to practice. Not watch me, but to practice. Okay. So let's jump into it with question number 1. We've got a quadrilateral PQRS. It's constructed with QR is equal to 50 as shown, 51 as shown. That the diagonals of PQRS intersect at 90 degrees at point T, so that PT is 32 and QT is 24. Okay, so I like that we've got some right angles here. It immediately makes me think, oh, I should probably use Pythagoras Theorem, figure out some of the other side lengths, and go from there. But that's just an immediate thought upon seeing right angles and lengths. I don't know if we actually need to do that. So we got 3 questions here, 2 light bulbs and a written. First question, 1A, calculate the length of PQ. Well, PQ is just the hypotenuse of this smaller PQT triangle. Okay, so Pythagoras to the rescue. So we'll open up our notepad. So I'm not going to draw the whole figure right now, PQT, but I will say things like, notice PQT is right-angled, and we had, 24 and 32 here. So by Pythagoras, PQ squared is equal to PT squared plus TQ squared, which is 32 squared plus 24 squared, which is 1024 plus 576. Remember, calculators are allowed, so you can absolutely use them. And those will add together to give us the 24 and the 76 will be 100, 600, so 1600. So that tells me PQ is equal to 40. Okay, had basically a single sentence, a picture, and just some calculations, but having that there would be enough to ensure that if I made a goof, maybe it's actually 50 and I added wrong or something, I still have enough there that I can get a bunch of part marks. Okay, and if we're trying these contests and we actually want to do well, it's about maximizing our score. Okay, so we do have to keep that in mind. Okay, another thing to keep in mind, just while we're talking about score, each question is worth 10 marks, and the contest is laid out. Question 1 is supposed to be the easiest, then question 2, 3, and 4. That said, maybe you'll take a look and you actually find 4 easier than 3, that sort of thing. But the point being, if they're all equally weighted in terms of marks, you should be trying questions 1 and 2 before just jumping down to question 4. It's harder, it's less likely that you'll get it, whereas you could be spending most of your time doing 1 and 2, getting 20 out of 20. Okay, so that's something else to keep in mind. So that's A part. We've got 40 here, and we could add that to our diagram. if we wanted to, but let's see if we need to. B part. Calculate the area of PQR. Okay, so now we're sort of at the top half of this this quadrilateral PQRS. So I know that we've got a 40 there. How do we calculate areas? Well, it's a triangle. So if we had a base and a height, well, PR would be a fantastic base. And we know the height's going to be TQ because it's an altitude. It makes a right angle here. So if I knew the length of PR, I'd be all set. Well, I know part of it's 32. What's the rest of it? TR over here. Well, that's part of another right angle triangle. Okay. So I draw the picture here. Just the top half. No more than we need. 24. I'll add the 40 in just because we worked it out, but we're not actually going to use this 40. We got 32, and we were told that QR is 51. Okay, and we got a right angle here. So I might say first, Pythagoras' theorem, RT squared is going to be QR squared minus QT squared. Notice that usually when you state Pythagoras' theorem, it's, a squared plus b squared is equal to c squared. But any of these rearrangements are equally valid, and it saves you a line of writing. Okay, so RT squared is 51 squared minus 24 squared, and that's what? So 24 squared, I know that's 576. 51 squared, well, that's 50 plus 1 squared. 50 squared is 25 or 2500. And then it'll be plus 2 times 50, so that'll go up to 2600 plus 1. So 2601 should be our answer. And then when we subtract, so taking out the 76 from the 101 would give us a 25, and then 25 minus a 5, 2025. And we recognize that as 45 squared. So RT is going to be 45. Now I say we recognize that. You don't have to have every number memorized and it's square and it's cube or anything like that. If you need it, use a calculator. But I like, for the easy questions, just sort of stretching my brain. Can I actually just do it in my head? Because there have been times in the past I've forgotten my calculator and I want to know that I can actually do math rather than press buttons. But whatever's fastest for you, you go with that. Okay? So we get 45, and if I wanted to, I could even confirm it. If I were actually doing this on a contest, yeah, I'd probably bust out my calculator. But I'm not doing the actual contest right now. So, I get to sort of play around. And why does it keep doing that? I get to play around and just sort of test my brain there. Alright, so we can add 45 down here. So PR is 32 plus 45. It's PT plus TR. So it's, 77. Okay. And we wanted, ultimately, the area of PQR. Well, that's going to be 1/2 base times height. So that's going to be 1/2. Our base is 77, and our height is 24. So 77 times 12, I'm going to break that up. Again, trying to do this mentally. To 7 times 11 times 12. 7 times 12 is 84. And there's a nice trick for multiplying a 2-digit number by 11. 8 and the 4, and then we add them together, we get a 12 in the middle. So 2 and carry the 1. So 924. Okay. So we'll just clean up that 9 ever so slightly. Okay. But again, if you needed to, grab the calculator, 24 times 77 divided by 2. 924. Okay, so we got it right there, and we have the right area. Okay, so that's it for our light bulb questions. Now the next one here is a written question. So let's take a look here. So C part, we do have to actually write up, use full sentences, explain what we're doing, but we've basically been doing that as we go. You might just add a little bit more explanation or actually state results before you use them. But if QS to PR, so QS is one of the diagonals of this quadrilateral, PR is the other one. So if they're in a ratio of 12 to 11, determine the perimeter of quadrilateral PQRS. Okay, so we want the perimeter. So perimeter would be PQ plus QR plus RS plus SP. Well, I know what PQ is, and I know what QR is. I've had those worked out from A, and of course the 51 was given to me. But I don't know what RS and PS are. But again, we've got some right angles here, and I know TR and I know PT. So if I knew ST, Pythagoras would save the day, and then we'd just add up each of those hypotenuses. So can I figure out what ST is? Well, it's going to be QS minus 24, and QS is in a ratio with PR, which I know from B part. So it's always a good idea before you, do work on rough work, but before you actually start writing something up for the solutions, because part of this is being clear and not wasting space and things like that. You want to have a plan of attack. I'm going to write up this part, then this part, then this part. Okay, and that's a great way to be clear. Use full sentences. This is how we get good marks. All right. So I've got my plan of attack, even for if I was going to sort of work on rough work, but we'll flip the page. So QS to PR is 12 to 11. And I would say from B, I know, or we know, PR is 77. Well, ratios, they're not the easiest thing to work with. Basically, for every 11th of PR is the same as a 12th of QS. So we can actually rearrange this if we wanted to into a fraction. So QS over PR is 12 over 11. This would be a great way to do it. Plug in your 77, and you'll get QS as 84. Another way to do it is ratios. So QS to PR is in a ratio of 12 to 11. If there exists, so we know there exists some K, so that QS is 12K and PR is 11K. And then you could say, well, 11K is equal to 77, K is going to be 7, so what's QS? So there's lots of different ways to go about doing it. Okay, I'm going to use, we use the first one I used. So this translates to QS over PR is 12 over 11. So QS over 77 is 12 over 11. QS is 12 times 77 over 11. Didn't we work out 12 times 77 a little while ago? Doesn't matter because the 11 and the 77 divide to give us a 7, and we get 84. Okay, so QS is 84. I'm going to bring out the big picture. I admit it's not quite a right angle, but it's okay when we do diagrams. As long as it's vaguely right and it makes sense to us, that's good enough. So we had a 45 there and a 51 there. And it was Q, T, R, S, and P. ST is QS minus QT, which we now know is 84 minus 24 is 60. So I'm a big fan of putting a different color for something I've learned. So we get a 60 there. And using Pythagoras on PTS and RST, we see PS squared is 32 squared plus 60 squared, and RS squared is 45 squared plus 60 squared. Now, I've been using calculators and working this out. Another thing you can do is recognize Pythagorean triples. So 45, 60, these guys have a common factor of 15. This is just a 3, 4, 5 triangle multiplied by 15. So this is actually going to be 75 squared. And RS is going to be equal to 75. Now this is a little unsatisfying. And if this were a bigger part of the question, I would probably, write it out or something like that. But I think you can probably just quickly jump to it. And the 32 and the 60, some multiples of 4, 8, and 15, and 8, 15, 17 is another, it's a less well-known Pythagorean triple, but there it is. So we want 17 times 4, which is 68. So PS is equal to 68. And again, if you're worried, double check. I'm just going to double check the 32 plus 60 times 60. Yeah, 68. Okay. So, the perimeter, that's equal to PQ plus QR plus RS plus SP. And now we know each of these lengths. 75 was next, and then 68. Make it a little clearer, that 75. Okay, and we can add them up. I'll take the 1, the 5, and the 8, and that becomes 14. 14 carry the 1. 1 plus 4 and 5 is 10, and then that's 13, so 234. Okay, but as usual, if you want to, of course, you can double check with a calculator. You don't have to. If you're confident in your adding skills, 234, there it is. But notice how much work we did. Okay, we started with the ratio. We explained, I already know that PR is equal to 77. So I change the ratio to a fraction. I get QS. From there, I know ST. And then using the Pythagorean theorem twice, and we're all set. It's important to keep in mind, and they actually say it in this one, short answer questions are usually worth 2 or 3 marks. Okay, so when we write up a solution, as opposed to, say, just a final answer question. Final answer, if you want to, of course, you can just leave it with your final answer. But when we write up a solution, we sort of have to think, am I hitting all the major themes? Am I hitting the things that are worth marks? And so, how many marks would C be worth in this case? Well, I know A and B are short answer. So they're worth 2, maybe 3. Let's lowball it. They're worth 2 marks each. That's 4 out of 10 already accounted for. C part, do I feel like I've done 6 marks worth of work? Well, let's take a look here. Rearranging the ratio, recalling previous information, calculating ST, using Pythagoras twice, and final calculation. Yeah, maybe. Maybe this one isn't worth 6. Maybe the first 2 were both worth 3 and this guy's worth 4. Then I've definitely done enough work. Practicing these contests, seeing solutions, not necessarily mine. Of course, you can click the second link. It'll take you to the CEMC's past contest, and you can look up solutions to this and other contests. You can see how much information do they give, how much information do I give, and how much information are you giving when you practice these things. You slowly learn how much you need to give, how much needs to be written down, what sort of things need to be written down. Okay? And so that can better refine your, I don't want to write paragraphs, but I don't want to say, by Pythagoras, these things, and we're done, and my final answer is 234 without even showing that I understand what a perimeter is. Okay? But I think that's enough rambling. Let's move on to question number 2 on the 2012 Hypatia, and we'll do that in the next video. So thanks for joining me, and have yourself a wonderful day.